Hello, welcome back. So in this part, we are going to solve a problem which will be based on determining resultant of the forces more than two. So if on a point, if uh, forces are acting and those forces are more than two, so in that case, generally we find out resultant using the rectangular component method. So how do we find out that? That we will see. So first, this is the problem. In this, we have to find out magnitude and direction of the resultant force for the system of concurrent forces shown below. So first I will show you the diagram. So there, this is the diagram, it is shown. So this is actually again a boom hook, and on this hook there are three forces acting. One force is acting exactly along the x-axis. The second force F2, it is acting inclined, and it is inclined from the vertical axis, which is y-axis. So from y-axis it is inclined at 45 degree. And similarly the third force inclination, it is shown by the small triangle. So it is basically shown as the slope of the angle. So basically on this point there are three forces acting: F1, F2 and F3, and we are supposed to find out resultant of all three forces. So we have to find out one single force which will be having the same effect as these three forces having on the same point. Okay, so first of all, what we will do is we will convert the inclined force into the vertical and horizontal component. So F2 force is inclined. So F2 force will be having two component, one component along the x-axis and the second component along the y-axis. So it is making angle with respect to y-axis. So that also we have to see. So now you can see F2 is converted into two component. One is along x-axis, this one, and one is along y-axis, this one. Okay, so now 250 Newton is converted into two component. One is along x-axis, one is along y-axis. Similarly, the second force F3, it is again converted into two component. One is along the y-axis and one is along the x-axis. And the third force, which is F1, you can see F1 is directly along the x-axis. So there will be no other component of this force. Why? Because this is exactly along the x-axis. So generally, the force will have two components only when they will be inclined with respect to x or y axis. So like F2 and F3, they are inclined with respect to x and y axis. That is why they will be having two components. But if there is a case like for the for the force F1, so F1 is directly along the horizontal line, so it will be having effect along the x-axis only. It will not be having any effect along the y-axis like these two forces have. Okay. So now in the solution, what we have to do is we have to resolve all the forces along x-axis and y-axis. So in the diagram, they are already resolved. So 250 is along the horizontal axis and along the y-axis. Similarly, 200 is along the y-axis and x-axis. So we will find out their value, their component value. So first of all, we will find out the x component. So along the x-axis, we have three forces: force F1 and x component of force 250 and x component of force 200. So basically we are having three forces. So summation of these three forces will be written as summation of Fx is equals to, so first force is force F1, which is 400, and the direction of this force is leftward. So we know that upward and rightward force is positive, downward and leftward force is negative. So you can see 400 Newton force is negative because it is leftward. So I'm writing here 400 Newton. Similarly, the next force is F2. So the horizontal component of F2 for I mean the component of F2 along the x-axis, it would be 250 sine 45 degree. Why? Because it is making angle with reference to y-axis. So in that case, the triangle, right triangle will become like this one. Okay, so this will be shown as 250 cos theta, and similarly this will be shown as 250 sine theta, or the same value will be this one also, 250 sine theta. So all the values I have written here, you can see here. First force F1, and this is the F2 sine 45 degree, and this one you can see this one is given in the form of slope. So to find out the value in terms of the slope, so you can see here, so what we can do is we can segregate this single force. So this single force is shown like this, and the triangle on this force is become like this, 3 4 5. So this triangle will make a right triangle like this. So this component and this component, so this component will be having fx and this component will be having fy. So fx in this case would be f, if I write this as f, so f into 4 by 5. Okay, so the same things you can see here. So f value is 200, and in the bracket it is 4 by 5. So 4 is parallel to fx, that is why I have taken 4. And we have to find out actually here the ratio of 4 by 5. And after calculation, we find the summation of fx as minus 383.2 Newton. Now you can see the value of summation of fx is negative, which means the horizontal force, summation of horizontal force is towards the negative x. So I have written here the language. The negative sign indicates that summation of fx acts to the left. So like this is the x-axis, y-axis, this is positive x, and this one is negative x, which means the summation of fx is towards the left. That is why this is showing the negative sign. Now why it is happening? This is happening because of the contribution of the three force, like contribution of 200 force and contribution of 250 force and 400. More contribution is towards the left because 200 force is again towards the left and this force is again towards the left. So that is why more negative value than the positive. Like you can see here, minus and minus. Now we will find out the vertical summation, which means summation of fx, sorry, summation of fy. So in the summation of fy, only two force will be considered because as I said, f1 will not have vertical component. So in that case, we will be having only two force in the vertical part, vertical component of f2 and vertical component of f3. So that is shown here. So the vertical component of 250 force will be 250 cos 45 degree. So this force will be like this one. So this is written as F2 cos theta. Similarly, for F3, it is again along the vertical direction and this will be 200. So as you can see here, again, if we make the diagram, So there is a small triangle which is 5, 4, 3. So this time we are going to find out this Fy, and this one is F. So in that case, this will be Fy is equals to F into 3 by 5. So this is how it is being written here. Okay. So summation of Fy after solving, it becomes 296.8 Newton. So now we have got both the value, summation of Fx and summation of Fy. Now we can represent that in the X and Y plane. So as I said, that summation of Fx is on the negative side. So that is why the direction of the Fx force is towards the left of X. Similarly, the value of summation of Fy is positive. You can see here. The value is positive. So which means it will be towards the positive y-axis. So that is why the resultant fall in the second quadrant. So like I said, this one is positive, 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 negative, 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 positive. So this time it is falling in the second quadrant. So that is why the resultant is shown like this. So summation of Fy is 296.8, summation of Fx is 383.2, and resultant will be in the second quadrant, and the direction of the resultant with horizontal axis will be theta. So both of them can be calculated using the formula Fr as under root Fx square plus summation of Fy square. Putting all the values, the resultant of force is written as 485. So this magnitude of this Fr is 485 Newton. And the theta is calculated as using the direction, this one, tan inverse in bracket summation of Fy Fx. So in the bracket, value of summation of Fy is 296, value of Fx is 383. Now we are not using negative because negative will not be significant here. Why? Because we have taken account of negative because we have provided our resultant in the second quadrant. So that is why there will be no significance of putting negative with 383. Okay, so putting the value, we can find out theta as 37.8 degree. So this theta is 37.8 degree. So now if you see in the previous slide, so now all three forces are replaced, F1, F2 and F3. So their resultant will be in this quadrant, it will be towards this, like this. And the angle between them we have just calculated, I think it is around 38 degree. So all three forces is replaced by the single force, and the magnitude of this, I think it is 495. On the next page, I think I have calculated, sorry, 485. The magnitude is 485 and the direction is 37 degree. So this is how we find out the direction and magnitude, and we represent that in the diagram also. So that is the solution of the problem 3. So we will continue our topic in the next lecture. Thank you.